right? So in the today's session, we're going to see interface. And so before that, so we have seen some of the object-oriented programming concepts in the last classes, and the class, object, then encapsulation, polymorphism, and then we have seen inheritance, right? So these are the concepts we have covered so far. And today we are going to say one more concept of object-oriented programming, which is data abstraction. So this is another concept of object-oriented programming concept. So the data abstraction we can achieve in two different ways, by using abstract class and also by using interface concept. So for every object-oriented programming concept, there will be a technical concept associated with that. For example, if you want to achieve polymorphism, right? Overloading is a concept. Through overloading, we can achieve polymorphism. So by using setters and getters, we can achieve encapsulation. So like this, data abstraction also we can achieve by using abstract class and also interface. So first of all, let us understand what is data abstraction. Abstraction means what? Hidden. So the functionality is hidden. So that's called abstraction. So what is data abstraction means? So it's a process of hiding implementation. As per Java definition, it's a process of hiding implementation and only showing the functionality to the user. Abstraction is a process of hiding implementation details and showing only functionality to the user. What does it mean? Let me take some examples. Suppose we are using some device. Suppose we are using mobile phone. We know how to use mobile phone, right? But how they have implemented all the apps and how they have developed internal hardware, all those things we don't know, right? We are using the device, but we don't know exactly what they have implemented internally. So that is part of the hidden, right? So like this, in the real life, we can see so many things. We are still using it, but we don't know exactly how they have implemented, right? So like this, that's called abstraction. So abstraction is nothing but a process of hiding the implementation, but only showing the functionality to the user. We can use it, but we don't know exactly how they have implemented. So that is the meaning of data abstraction. Abstraction is a process of hiding implementation details and showing only functionality to the user. So this is also a kind of a security and a privacy kind of a feature. Like encapsulation earlier we discussed, right? So we can access the data only through setters and getters. We cannot directly access the data. Okay, and similarly here also we can indirectly access all the methods and variables. We cannot directly access. That's abstraction. So this we can achieve using two different approaches in Java. One is by using or by creating abstract class. And the second approach is by using interface concept. So these are two different concepts which we have, through which we can achieve data abstraction concept. And again, if you take these two concepts, abstract class, by using abstract class, we cannot achieve 100% abstraction, but by using interface, we can achieve 100% abstraction. So interface is more advanced concept than abstract class. Abstract class, interface, the objective is same, the purpose is same. Okay, but when you compare again, these two, interface is more effective than abstract class. Okay, so interface is having more number of features, and we can achieve more high level abstraction by using interface. 100% abstraction we can achieve, but when I use abstract class, there are some loopholes are there. So that is the reason we cannot achieve 100% abstraction. So if you compare these two, interface is more preferable when you want to achieve data abstraction concept. Okay, so we will directly start with interface, and we will understand interface and all those stuff. And once you understand the interface concept, later I will compare interface with abstract class. Okay, then you will understand what is the difference between these two and what are the limitations of abstract class, what we can additionally achieve by using interface concept. Okay, because these are all security and privacy related features. We no need to focus more on this. But interface is most important because most of the times in automation also sometimes we use interface concept. We will try to use some existing predefined interfaces which are already there in Selenium WebDriver. So for that, we have to understand interface. So we directly jump into the interface. And once you understand interface, then finally we will compare and how to create an abstract class and what is the difference between interface and abstract class. Interview perspective, this is most important, but practically we never use abstract class. Okay, if you want to achieve data abstraction, directly we will use interface concept. But interview perspective, you need to understand the differences between abstract class and interface. Okay, so directly we'll start with interface concept, and which is very, very important topic. And you have to focus each and every point what I'm saying. And I will also show you the practical examples for every point. Okay, so let me put some points here. What is an interface and all other points. So first thing, the first point, we already know about class, right? What is class, what is object, and what is class contains. Class contains the variables and methods, and we can create an object for the class. So we already know these points. Now, when you come to interface also seems very similar to the class, but interface is having some more attributes, some more type of behavior. And there we can differ class with interface. Okay, so first we will see what is an interface. An interface is a blueprint of class. An interface is a blueprint of class. What does it mean? When you create an interface, the syntax is almost similar to the class, just that the keyword is got changed. Suppose if you want to create a class, you will say class keyword, class name, and then the class contains the variables and class contains the methods. This is syntax of the class. When you create an interface also, we use the same syntax, but only the difference is we use interface keyword. Instead of class, we use interface keyword and interface name. And the interface also contains the variables. And interface also contains the methods. So syntactically seems very similar. Only the class keyword is difference. And class contains the variables and methods. Even interface also contains the variables and methods. So that is the reason we can say an interface is a blueprint of class. So when you're creating an interface, almost the syntax is similar. So which is the reason we can say an interface is a blueprint of class. And again, I will tell you when we have to use interface. Okay, what are the advantages you will get interface with real-time scenario, I will show you. First, we will understand what is interface and how to create and how to work with it. Now, the second point, an interface contains a final and static variables. Interface contains only final and static variables. Means what? When you create in the class, we can create any type of variables. We can create static variables, we can create non-static variables, we can create final variables, we can create non-final variables. Every type of variable we can create in a class. But in interface, we can create only final and static variables. And even if you're not specifying these keywords, still, if you just create a variable in interface, that will be treated as final and static variable. Both keywords are applied for that particular variable. So in interface, the variables are by default final and static. Okay, you don't need to specify the keywords, final keyword, static keyword, but as soon as you created a variable, that is a final and static variable by default. Okay, so interface contains a final and static variable. So what is the meaning of final? In the last classes, we have already discussed about these keywords. What is the use of final keyword for the variable? When you create a final variable, the value of the variable is constant. Okay, we cannot change. Similarly, what is the use of static variable? When you create a variable is a static, that is a common variable across all the objects, shared variable. Okay. So by default, whenever you create a variable in interface, that is final and also static. And we no need to specify the keyword also. By default, the variables are final and static. That's the second point. Now the third point is interface contains abstract methods. Also allowed default methods and static method from Java 8. From Java 8, before Java 8 versions, interface allowed only abstract methods. We can create only abstract methods. But after Java 8, we can also create default methods and static methods in interface. So this point is most important. We need to understand. What is an abstract method? Interface contains the abstract methods initial days. But after Java 8 onwards, they also allow to create default methods and also static methods in interface. And what is an abstract method? Abstract method is just like a normal Java method, which is having only the declaration part. There is no implementation for this method, which is called abstract method. Okay, for example, in the class, if I create a method, how we will create? We will specify the return type, then method name. And if you have parameters, you can specify parameters. And here you will implement. Implementation we will have. In case of interface, we will have abstract methods. Abstract method means what? Only you have a signature, means return type, method name. And if you have a parameters, you can specify the parameters in the bracket and then semicolon. So this is only signature. There is no implementation. So this type of methods are called abstract method. So abstract method means which is having only signature. So an abstract method is a method contains a signature but not body, which is also called unimplemented method, which is also called unimplemented because we haven't implemented that method. We have just declared that method in the interface, but we haven't implemented that method. So such type of methods are called abstract methods. So when I create an interface allowed to create abstract methods. So before Java 8 versions, interface allowed only abstract methods. We cannot implement this method. Okay. By default, this method is an abstract method. We cannot write implementation. Just like a class, if you're trying to implement this method like this, it will give you an error because implementation not allowed in interface. Here we cannot implement. So the body we cannot implement in the interface. The method body we cannot implement in the interface. It is not allowed. So only abstract methods are allowed in Java. But from Java 8 onwards, it is also allowed default and static methods. Means what? These methods we can have implementation. Default methods and static methods we can have implementation. Implementation also we can write, but only abstract methods doesn't have any implementation. Okay, this is point very, very crucial. So interface contains abstract methods, means there is no implementation, only the declaration will be there, only signature we can write, and the method should end with the semicolon. So this type of method is called abstract method. Just a moment, guys. Okay. So the interface contains only abstract methods. From Java 8 onwards, interface is also contains a default methods and a static methods. So default methods and static methods can have a implementation, but abstract methods doesn't have any implementation. I will tell you what is default method, static method, everything. So by default, whenever you create a method, the access modifier will be allocated for that. That is called default. Default is an access modifier. These are all not built-in classes, methods, or anything else. Don't assume like this. I will explain each and everything clearly. Okay, just try to understand this point. Okay, while creating an interface, I will tell you what is abstract method, what is default, what is static, all those things. Now the fourth point. So first we will understand all the points, then each point I will implement practically and then I will show you, okay? Now the fourth point, we already understood. Abstract method is a method, contains signature, but not body. Means we already understood there is no body for the abstract method like this. Only return type, name of the method. If you have any parameters, you can have this parameter. That's semicolon. There is no implementation. That's type of method called abstract method. Fifth point. So the methods in interface are public. So by default, whenever you create a method or whenever you create a method in interface, by default, they are public. Public means is an access modifier. And normally, if you want to make a method as a public, we have to write a keyword like this. If it is a class, if you want to make the method as a public, we have to specify the public keyword. Then only this method become public method. Everywhere we can access. But in interface, even though you don't specify this public keyword, by default, the method is public. The methods are public. Okay. So all methods in interface are by default public, even though you don't specify access modifier. But in a class, if you create any method like this, you don't specify any access modifier. Then what is the default access modifier will assign to this method? In case of class. In case of interface, by default, the methods are public. Even though if you have not assigned any specific modifier, that is a public. But in class, if you don't specify any access modifier in front of the method, what type of access modifier it will allocate? It is default access modifier will allocate. In case of class, default access modifier will be allocated. Okay, remember this. So you no need to write the default keyword actually in the class. So even if you don't write it, by default, this is a default method. This is the default method in the class. Okay, but in interface, the methods are public. By default, the methods are public. If you want to make a method as a default, you have to specify the default keyword if it is an interface. That is a major difference. Okay. So anyway, we will compare this with the class later. First of all, focus on interface. So interface contains a, by default, all methods are public in interface. Now the sixth point, interface supports the functionality of multiple inheritance. So what is multiple inheritance? We have multiple parents having one child. So those parents, we can create an interfaces. So multiple interfaces we can implement by using single class. That single class is a child class. But if you have a multiple parents classes, so we cannot extend, we cannot implement. So by using interface, we can achieve multiple inheritance. Next, we can define interface with the interface keyword. We already seen. Now the eighth point, a class extends another class. So suppose if you have two classes, which keyword we will use? One class to another class if you want to extend. Extends keyword we will use. Similarly, an interface extends another interface. So if you have one interface, parent interface, I want to get everything into child interface, still we use extends keyword. But a class implements another interface. Class to interface, we can do implementation. Okay, so I will clarify this point. So just observe this. I have one class. Let's say this is my class, C1, and another class. Class to class, we use extends because this is the extension of the previous class. Then C2 will get everything from the C1. And both are having implementations. Now I have an interface and another interface. And this is a parent interface, this is a child interface. Now I want to get everything from the parent interface to child interface. Here also we use extends. Interface to interface also extends. This is the extension of the previous parent interface. Now I have an interface. And what is an interface contains abstract methods along with the default and static methods. So default and static methods, anyway, we will have an implementation. But only the abstract methods doesn't have an implementation. So if you create an interface, we need at least one class. This class will implement all the methods from the interface. Anyway, default methods and static methods will be implemented. The implementation is there. Only our concern is about abstract methods. So interface contains abstract methods. Abstract method is nothing but what? There is no implementation. But who will implement those abstract methods? Interface cannot implement. Only interface contains the abstract method declaration. So if you want to implement those abstract methods, we need at least one class. Suppose if I create one method here, which is abstract method, and this particular method we have to implement in child class. So here we have to use implements keyword. So class to class extends. Interface to interface also extends. But interface to class, we have to do implements. But class to interface, tell me, class to interface, extends or implements? Suppose I have a one class and child as an interface. Extends or implements? This is not possible. Class to interface is not possible. Why it is not possible? See very carefully. Interface contains a abstract methods, default methods, static methods. So we don't worry about abstract. We no need to worry about static methods and default methods because they are already having implementation. So child class also will get that implementation, no problem. We have concern about only abstract methods. So in interface, abstract methods will be there. Means there is no implementation for abstract methods. So those methods we can implement using a class. So that's the reason we have to use implements class. But if you look at this particular scenario, what is class contains? Class contains what? All types of methods, right? Static methods, default methods, implemented methods. All methods are implemented here. But when you get all of them in interface, but here interface not allowed implemented methods, right? So class contains implemented methods, but how come interface will get the implemented methods? Interface not allowed, right? So implements interface not allowed to create implemented methods. Only abstract methods are allowed. But when you get class into interface, here interface should allow implementation also. But by default, interface doesn't allow the implementation. Only abstract methods are there. But in the class, we have implemented methods. So how can we get implemented methods into an interface? We cannot. So that's the reason this combination is not possible. So class to class, we use extends. Interface to interface also we use extend. Suppose if we have some abstract method here, same abstract method will come into I2 also. But again, if you want to implement this abstract method, again, we have to create one more class here. Here we have to do implements. Got my point? So interface alone is not useful. Interface along with the class is useful. Whenever you see an interface which contains an abstract methods, what is the use of abstract method? What is the purpose of creating a method? First of all, we need to write some logic inside that, right? When I create a method, there is some purpose. That method should perform some task. But if we simply create an abstract method, what is the use of that method, right? So somebody should implement that abstract method. Then only it will be useful. But interface cannot implement. So we need to take the help of a class which will implement those abstract methods which are coming from parent interfaces. So interface alone is not useful. Interface along with the class is useful. So class We need to implement all the methods, abstract method from the interface. Okay. So just like a class, we can also extend from interface to interface. Suppose this interface is already designed by somebody else, and we want those variables, we want those methods. So again, we no need to recreate them in our own class. We can just extend that interface into our own interface. Then automatically we will get all the variables and all the methods from the parent interface to child interface. Just like a class, how we have used inheritance concept. This is also inheritance. Inheritance is applicable in class as well as interface. Okay. So what is the use of extend in the class? In the last classes, we already discussed what is the use of inheritance. Same thing here also. If something is created already in interface, and instead of recreating again and again multiple times and avoid duplication, we can simply extend that interface to another interface, so that we will get everything from parent to child interface. Again, these methods we can implement by using any other class. Okay, class to class we use extends. Interface to interface also we use extend. Interface to class we use implements, because this interface should be implemented by using a class. And class to interface is not possible. And why it is not possible? Because class contains implemented methods. Once you implement or once you extend, interface not allowed implementation. So you cannot get it. So this is a point. 8th point. Class can extend another class. An interface extends another interface, but class implements an interface. Okay. Is this point clear, everyone? 8th point, which is related to inheritance. Now the last point. We can create object reference for interface, but we cannot instantiate interface, which is another important point. That means we cannot create an object for interface. If we have a class, we can create an object for the class. But for interface, we cannot create an object. We cannot create an object. That means we cannot instantiate. Here there are two terms actually. Object reference, instantiate. We need to understand the difference between these two. Object reference, instantiate. What is this? Suppose if you have one class created, let's say we have created one class A. Okay, let's say I have created one class called test. Now for this particular class, how to create an object? How to create an object? By using new keyword. So new test. If you leave statement like this, I'm not using any reference variable here. Just I'm saying new test. This will create an object. So new keyword will create an object of test type. But if you want to work with this object, we need some variable. Reference variable is required. Even though if you don't have a reference variable, still we can work with the object. I will tell you, earlier we haven't discussed this. Suppose if you want to create a class, suppose you have a class called test. And how to create an object for this? We can say new test. This itself is an object. Okay, suppose I say new test. This is another object. Again, new test. This is another object. So 3 objects will be created like this. 3 objects will be created. So if you want to work with this object, you can say new test. So we can directly refer this. Suppose if there is some variables or there is some methods here. How can we access with this? You can directly access like this. New test dot method name. You can directly do that. So this is the object. From the object, I'm accessing M. Okay. So instead of using this every time, what we can do, we can put some reference variable. Okay, some X test type. So by using X, we can do X dot M. This is the way we are using currently. So actually, who is object reference here? This part is called object or instantiation. We can call it as an instantiation. Okay, instantiate or instance or the object. But what is this X? X is not an object. X is a reference variable. This variable is pointing to the object. You understood the point, everyone? So actually, who is an object here? This part, this is called object. This is called object. This is called object. This will new keyword will create an object. To refer this object, we are using some variables. So object reference means what? This one. This is called object reference variable. Instantiate means what? New test. This is called instantiate. Okay. You got the difference, everyone? What is object reference variable? What is instantiation? Instantiation means what? The process of creating an object. That is called instantiation. So here, where we are creating an object, here, new test. This is called object creation. So this part is called instantiation. So now, based on that, we will understand. If it is a class, we can instantiate. We can also create an object reference variable. Both are possible. But if it is an interface, we can create only object reference variable, but we cannot create instantiation. That means we cannot create an object. But without creating an object, how can we create reference variable? Why do we need reference variable? You got my point? If you create an object, if I say new test, object is created, then we need some variable, test type of variable we require. So this particular variable is referring to this object. When you create an object, then object reference variable is needed. But in case of interface, if you are not able to create this object, why we need this interface type of variable? Object reference we can create, but we cannot instantiate. Means object we cannot create, but object reference variable we can create. How come it is possible? That is the point. Okay. So how it is possible means, for example, if you have an interface should be implemented by using some class. There must be some class. Without class, there is no use of interface, right? So as soon as you create a child class, what you will do in this child class? Whatever methods are there in the parent interface, you will get everything into child class. Abstract classes or abstract methods also you will get into the class. So these abstract methods we will implement using this class. Now we can create an object for this class. Okay, I say new C, this will create an object. And normally what you will do, whichever class you created an object, we will create a variable also with the same class like this. So we created an object for the C class. So the variable type is also C. This is a normal way we do it. But suppose if this class is a child class of interface, then what we can do is the object we have to create for the class, but the reference variable we can create for the interface. This is the point. That means the variable of interface can hold the object of child class. Okay, when you can create an object for this child class, that object we can hold into another variable. That variable can have interface type. So forget about this one. Just think about this one. This is clear, everyone, right? So whenever we create an object for the class, we can hold that object into a variable that is also type of the same class. Whichever class we created an object, the variable type is also same. This is clear, everyone, right? Now come to the interface concept. When you come to the interface concept, we cannot say I obj equal to new I. We cannot use new keyword for interface because we cannot instantiate interface. We cannot create an object of interface. So then what we will do now, if you want to access everything from this interface, what you will do now? We will create an object of the class, which is implemented this interface. You have to listen very carefully. We cannot directly create an object for the interface. Then if you want to access everything from the interface, what you will do? You can access them through the object of class. So some class will be there, which is implemented this interface, right? So we can create object of this class, and through the object, we can access everything or not, because this class is implemented everything from interface, parent interface. So we can create an object of the C class, and we can access everything by using this object. This we already know. But now, what is a new thing here is, new C, we created an object of C, right? For this object, we can also hold into the variable That variable type can be interface. So whichever interface is implemented this class, we can create a variable for interface, but we cannot instantiate interface. That is the point. That means whenever you create an object of the child class, that object we can store into same type of variable, or we can store into interface type of variable. That means an interface variable can hold the object of child class. This object is referring what? Child class, right? So the variable of interface can hold the object of class. This is the point here. Clear, everyone? We can create object reference, but we cannot instantiate interface. This point is clear, everyone. So why we need this, why we not, all these things I will explain. Need to have some patience, okay? You understand the point, difference between the class and interface with respect to this point. If it is a class, we can instantiate, we can also create object reference, both you can do. But in case of interface, we can do only object reference, but not instantiate. But again, another question will come. If we don't have instantiation, if you don't have an object, why reference variable is required? That is the reason I'm giving this example. So interface is a parent, which is implemented by using a class. So by default, when you create an object of this class, you can access everything from this one and this one. And object reference variable is same, and instantiation is also referring to the same class. But what I'm saying, if you create an object for the C class, this object we can also hold into variable. That variable type can be C, or this variable type can be I. That's what I'm saying. So if the variable type is C, that's fine, because the object is created for what? Class, this particular class. This is correct. And instead of C, we can also specify this interface name also. Instead of class, I can say I also here. That means this object is implemented for what? This interface only, right? That's the reason this object we can hold it into interface variable. So interface variable we can create, object reference we can create for interface, but we cannot instantiate interface. That means here we cannot write new I. We cannot write new I. That is called instantiation. So instantiation is not possible, but the reference variable we can create for the interface. And without having any object, how can we create a variable? This is an example. The object we will create for the child class, the variable can be interface variable. So interface variable can hold the object of child class. That is the point. Okay. So now we'll see practically all the points one by one. And then you will be able to understand very clearly. And one important question here. If interface contains abstract methods, what is the use of abstract method? Because the purpose of creating method is what? It should perform some task. If you just create an abstract method interface, which is having only signature, there is no implementation. What is the use of that method? That's the first question. The second question is, why we need to create an abstract method? When is a requirement? Whenever you start creating method, you will implement it. But if, without having any implementation, just creating the abstract method, what is the use? When you will create, who will implement that abstract method? Interface cannot allow implementation of abstract method. Then who will implement that class? Who will implement that method? And again, suppose, let's say I have an interface like this. These are all different questions. And this interface is implemented by using a class. First of all, why we have to create an abstract method here? Again, we have to implement this abstract method in the class. Same abstract method we will implement here. Why? We can directly create an abstract, we can directly create that method in the class itself, right? With the implementation. Why we specify abstract method, and why again implementing by using another class? This process is lengthy, right? So why we need to do all these things? So let me explain this with a real scenario. And we need to think this in the development point of view. Okay, then only we'll understand this. So why we need interface, and why we have to create abstract methods in interface. And later, why again we need a class, separate class to implement interface. Instead of that, we can directly create a class. We can directly implement that methods. Why the use of interface in that case? Okay. So interface is not only for multiple inheritance, guys. Interface is also having some other advantages. So let me just clarify that. What is a real usage of interface in the real projects and why we will prefer to create interfaces? Okay. So developer. So what is the responsibility of the developer? What developer will do normally? He will develop the software. For to develop the software, he has to, he will create, he will first what he need actually, what's the input he need. So if anybody want to develop a software or develop some application, okay, some application he want to develop as a developer. So what he need? Only requirement is enough. First thing is, he has to know the requirement. Second thing is what? Requirement means what? What to develop. What? Requirement says what to develop. If you know what to develop, then immediately you can start developing. Right? You don't know. Only you know what to develop. That says requirement. But how to develop? Right? You know, you should know that also, right? How to develop. That is called design. Okay, you have to, whenever you want to develop any software or any application, you have to know what to develop and how to develop. And how we will know what to develop? If you read the requirement document, so you will know exactly based on the customer or client requirements, you will know what to develop and what they are expecting from the application. But how to develop? Then based on the requirement, we have some kind of design. And based on the design, what the design contains, high-level modules, low-level modules, and again, each and every module, how many classes we have to create, every class, what are the variables method we should have. So this is all about design part. So if you want to develop any application, we have to know at least two things. We have to know requirement that says what to develop, and we have to know the design, how to develop. If you know these things, you can start development, right? This is a scenario. Now in the real time, what happens is, initial days, you will have only requirement. And design will take some time because design will not be available immediately. So once you get a requirement, based on the requirement, you will have a design documents. So this will take a lot of time. Creation of design documents will take a lot of time. But initial days, you will get only requirement. So with that requirement, as a developer, what you will do is, you will create interfaces. Okay, interfaces you will create. Whatever interfaces you need, you will create like this. And whatever you want to develop, you will understand the scenarios, right? And based on the scenarios, you will create abstract methods. Only signature, there is no implementation. Until unless you know the design part, you cannot implement those methods. Until unless you know the how, you cannot implement them. So initially, you have only requirement. For example, take a banking application. In the banking application, only fund transfer is one of the requirement. So here you will just create one abstract method for fund transfer. That's it. You will not implement this. Similarly, login, you will just create one method. And balance verification, you will just create an abstract method. Because of you know the requirement, but you don't know how to implement them. So initial days, developers will create interfaces like this because they know only the requirement part. They don't know the design part. So after a few days, after a few months later on, once they know about design part, then what you will do, these interfaces will implement by using again different classes. So not only one class, different classes can implement. Suppose if you create one interface, that can be implemented by using multiple classes with multiple implementations. Suppose if you have created fund transfer method, right? This method we can implement in the different ways in different approaches. So later, once you understand the design, once you get a design, then you will start implementing these abstract methods by using separate classes without disturbing this interface. So this is the real scenario. So there exactly we use interface concept. So initial days, we will just have only unimplemented methods, because we know only requirement part. We just specify all the requirements in the form of abstract methods. Later, once you know the design, you will implement these interfaces by using any other classes. Okay, so this is the purpose actually. So why we need interface and when we have to create an interface, and again later we need to create a classes to implement those interfaces. Okay, so now let us see the practical implementation of interfaces. All these points we will discuss one by one with the practical example. So now go to the Eclipse. Let's go and create new package for today. So day 16. Okay. Now in this, I'm going to create. Okay. So just like a class, we can also create an interfaces. Okay. So first I will create a normal class, because only interface is no use. Okay. We have to create a class also. So let's create a class directly. And here I will name it as interface demo. And main method also I'm taking. So this is the interface and along with the method. Let's keep, this is the class. Let's keep this class one side. Now I will create one interface. Just like a class, we can also create an interface. So by using interface keyword, interface, and I've give some name to interface called shape. Okay, now observe this. What is interface contains? Suppose if I create a variables, by default, those variables are what? Final and static variables. Okay, just observe here. I'm just creating one variable, int length equal to 10. See, as soon as you create a variable, it turn into italic. So this is a static variable. This is also final variable. You no need to write a static and final keywords. You no need to write anything like this. Okay, by default, that as soon as you created a variable, that is a final and a static variable. Remember this, final and also static variable. Similarly, I'm creating one more variable, int width equal to 20. This is also final and a static variable. So by default, the variables and method variables are final and static. Now, what type of methods it is allowed to create? 3 types of methods allowed. One is abstract methods, default methods, static methods. So abstract methods doesn't have any implementation, but default and static methods, we can have implementation. Okay. From Java 8 onwards, static methods and default methods are allowed, but in the old version of Java, initially only abstract methods are allowed. So I'm creating one default method. Observe very carefully. I'm creating one method here, void square. Just like a normal method I created. It is giving an error. Why it is giving an error? Because this is normal method. We have started implementation here. As soon as you put this curly brace, implementation is started. So implemented methods are not allowed in interface. We cannot implement the methods in the interface. Only the declaration is allowed. But here, as soon as you started the curly braces, I'm implementing this. Okay, suppose I'm writing some message here, system.out.println. Okay, I can say this is a square. See, I have already implemented this method. So these type of methods are not allowed in the interface. Then what we can do? And also by default, whenever you create a method, that's a public. So we have to make it as a default. Then this implementation is allowed. So the default methods are allowed in interface. Okay. And we can also create an abstract method. How to create an abstract method? Return type, name of the method, and then simply bracket and semicolon. This is called abstract method. There is no implementation. Okay. This is called abstract method. So the interface allowed abstract methods, default methods. What is a default method? Any method which is having default keyword in front of it, which is called default method. And the default methods are allowed. And one more type of method is what? Static methods also allowed. So let me create one more method, void rectangle. This is implemented. Implemented methods not allowed. Now I can make it as a static. So then it is allowed. So inside this, I can just write something. It's implementation. So this is rectangle. This is static method. Okay, and this is default method. So for this circle is abstract method, there is no implementation. So now when you create an interface, variables are by default final and static, and it is allowed three types of methods: abstract methods, default methods, and static methods. Abstract methods doesn't have any implementation, which is also called unimplemented methods, whereas default methods and static methods, we can have implementation. So this is the definition as per the interface. Okay. Now, who will implement these abstract methods? At least we need one class. One class. We should implement this interface by using any other class. So now come to the main class. So this is the class. This class can implement this interface. So now what I will do is here, I will write implements shape. Okay. So this particular interface I am trying to implement. As soon as you say implements a shape, everything, whatever is belongs to the interface, which will come into this particular class. Okay, now what is this class contains? Class contains variables, final and static variables, one abstract method, one default method, one static method. Everything will come into this class. Now this class giving an error. If you put this cursor here, what it is saying? The type interface demo must implement the inherited abstract method shape.circle. That means whenever you say implement interface, whatever methods are there in the parent interface must be implemented in the child class. Otherwise, it is not allowed. So why we are trying to implement this interface? Because the interface contains some abstract methods. So definitely we have to implement this method in the child class. Now let us try to implement that method. So at the time of implementation, same return type, same method name, and now we need to start implementation. Okay. So in the interface, we are not implementing, but here we are trying to implement. So void circle, same method name, void circle and bracket. Here we have to implement. So now implementing the system.out.println. This is circle, abstract method. Okay. Now I have successfully implemented whatever abstract method I defined in the parent interface, which is implemented. But still it is giving an error. Previously it was giving an error here. After implementation, now it is started giving an error. Can anyone know why it is giving an error here? Even though if you have implemented, same method is got implemented in the child class, why it is giving an error here? Can anyone guess? Okay. So yes, I told you one important point. Suppose if you create any method like this in the class, what is the default access modifier for this method? What is an access modifier we'll allocate to this method? Default. Okay, so this access modifier is default. If we are not specifying anything, default. So similarly, here, what is an access modifier for this method? Because this is implemented in the class, right? If I don't specify any access modifier, here, what is the default access modifier for this? Again, you're not understand. Just understand this. Let us take a class. In the class, I have created some method. I have not specified any access modifier. So which access modifier will allocate to this method? In class, I'm asking. Which access modifier will allocate to this method if I don't specify any access modifier? Default. Okay, so this method is a default method because we are not specified any access modifier. It is default in the class. So here, this method is got implemented. I have not specified any access modifier. So which one will allocate by default? Default access modifier will allocate because this is the class, right? In this class, we have written some method. And if I don't specify any access modifier, default is allocated. This is the default method now. Okay. But this method is coming from what? Parent interface. In the parent interface, what is an access modifier for this abstract method? Public. Got my point? So in the parent interface, this method is what? Public. But as soon as you implementing here, this becomes default. Earlier it was public. Now it will become default. So when you put the cursor here, it is clearly saying cannot reduce the visibility of inherited method from shape. Cannot reduce the visibility. Reducing visibility means nothing but what? Public is a higher level modifier. Default is a lower level modifier. Public is having more scope to access. Default is having very less scope to access. So which was is higher, public or default? Public is higher modifier. But what we are trying to do here, if I don't specify anything, that is a default. But what it is previously, it was public. Previously, it was public. Now I'm making this as a default. So public to default. What we are doing here, we are reducing the access. It is not possible. We cannot reduce the access. Whatever is access modifier is there in the parent interface, same access modifier should be there at the time of implementation. That's what my point. Okay. If you don't specify anything, default it is taking. Default is what? Lesser than public. So it is giving an error. So what is the solution for this? What is the solution for this? Yes. Whenever you are trying to implement abstract method, you have to specify public keyword. Don't forget this. Okay. Whenever you're trying to implement any abstract method from the interface, you should specify public explicitly. Okay. That is the point we have discussed here. Methods in interface are public. Okay. Whenever you're implementing those abstract methods in the class, you have to make them as a public. Okay. Is this point clear, everyone? How to implement abstract method in the child class? What are the necessary steps we have to take while implementing the methods? Okay, fine. So what about the two methods? This is implemented. Now square method, rectangle method by default will come to the class. And they are also having implementation. So we don't need to bother about that. So now tell me how many methods are there in this particular class, interface demo class? How many methods are there totally? How many methods are there in the interface demo class? Yes. 3 methods only, right? So these are the 3 methods we are implementing by using interface. So abstract method we already implemented and rest of 2 methods also come to this class. Totally 3 methods are there. Now let us try to access them by creating an object. So now how to access those methods? So all 3 methods are belongs to this class. Can we create an object of this class and access all 3 methods? Yes. Can we create an object for this class and then we can access all the methods? Yes. Let me create. So interface demo. For this, I am creating an object. Just ID obj. New interface demo. Is this correct or not? I can create an object reference here. Object I'm creating and object reference variable is also same. Got my point? When I'm creating an object, I'm using the same class. And also when I'm creating the variable also, I'm using the same class. We already know this. So by using this object, we can access methods, right? So let us try to access ID obj dot circle. What type of method it is? Abstract method, which we have implemented in the child class. Perfect. Now, ID obj dot square. What type of method it is? This is default method, right? Here we are calling abstract method by using an object. Here we are calling default method by using an object. Okay. And rectangle is what? Rectangle is what? Static method. Static methods we can call directly by using a class, right? By using a direct class, we can call static method. Object is not needed, right? So how to call shape method? Simply you can say shape. That's it. Got my point? Sorry. Rectangle. Because this is what? Static method. So this static method is belongs to what? This class. As soon as you implement shape, the static method is also belongs to what? Interface demo. So without creating any object, I'm directly calling the method. So still it is giving an error. Why it is giving error? Because we can directly access the static methods from the class, right? In the last classes we discussed. Static methods, static variables are common across everything. So we can access static methods and static variable directly by using a class. But here, because the class is also part of the same file, I'm not specifying any class. It is giving an error. Why? Because actually this rectangle method is belongs to the class. Actually, this rectangle method is belongs to what? Interface. Shape interface it is belongs to. After that, we are trying to get everything into the class. Now this rectangle is belongs to the class, right? But this is not direct method from this class. Got my point? This rectangle method we have not directly created in the class. If you directly created this method in this class, we can directly access like this without creating an object, without specifying the class name. But this method is not directly created in this class. We get it from the shape interface. Indirectly, we get it. So we have to specify the interface name, not the class name. Shape.rectangle. This is the way we can access static methods. Directly by using interface name, we can get it. Just if the static method is created in the class directly, then we can access the static method directly from the class. Or if the static method is created in the interface, we can access it directly by using interface. That's my point. Understood, everyone? So the static method can directly access from interface. Okay, this is a scenario one. Scenario one. So we created an object of the class. Through the class, abstract method, default method, we can directly access. This is, sorry, abstract method, default method, we are able to access through the object. But when you're trying to access a static method, we directly use interface name dot static method. Same rule is applicable here. Static methods we can directly access by using a class name itself. If the static method is created in the same class. But here the static method is created in the interface. So we can access static method directly by using interface name. So this is the scenario. Is this clear, everyone? We created an object for the child class. Then we are able to access everything. That is the point. Right. Now come to the next one. Scenario 2. Just observe. Very, very important. I'm just commenting this. Okay. Now in the scenario, I will show you the different thing. The first scenario, we have created an object for the class. Even reference variable is also class. Class type variable we created. Now, I will create the object for the class that we can hold interface variable, right? I told you this point. We can create object reference for interface, but we cannot instantiate. We can create object reference for interface. Shape sh equal to new shape. This is not possible. This is instantiation process. This is object creation process. So for the interface, we cannot create an object, but a reference variable we can create. But without able to create an object, why this reference variable is needed? Because even though if you're not able to create an object for the interface, still we can create an object for the class which is implemented the same interface. So here I can specify the class name instead of interface name. So now this will create an object for what? Class. And this class object we can store in the interface variable. Why we are able to store? Because this class is implemented this interface. That is the reason the variable of interface can hold the object of class, which is implemented the interface. Is this point clear to everyone? Is there any confusion? So the object of child class can hold into the variable of interface. Here what we have done, the object of the class, we have stored in the object of same class. But here, the object of the class, we are storing into the variable of interface. Why it is possible? Because this class is implemented this interface itself. There is a connection between this. Got my point? So the object reference variable we can create, but object we cannot create for the interface. Interface object we cannot create for the interface. The purpose of interface is totally different. We cannot compare with the class. Okay. Now, with this variable, what are all things we can access? Now observe very carefully. I'm saying sh dot. I want to access abstract method. What is the abstract method? Is what? Circle. Is it possible or not? Is it possible or not? Yes, obviously. So the abstract method we can access through the object. Now by using sh square, what is square here? Square is a default method. Circle is what? Abstract method we are able to access. Square is what? Default method we are able to access. What about static method? What about static method? Static method we can directly access with interface. There is no object required, right? So directly you can say shape dot rectangle, just like this. Earlier also we have done the same thing. So here static method can directly access from interface. Okay. So now when I run this, you will be able to execute. Okay. So this is a scenario. So in the first scenario, the object is created for the class and variable is also same type. And in the second scenario, object will be created for the class, but the variable type is interface. That is a reference. So the object of child class can hold into the variable of parent class. This is the ultimate point here. So is this example clear, everyone? So now if you go to the points, we covered everything. So an interface is a blueprint of class. Interface contains only final and static variables. Okay, and the interface contains abstract methods and also allowed default and static method from Java 8. Abstract method contains a signature, but there is no body, unimplemented method. Also, we have discussed when we need abstract methods to create. By default, all methods or interface are public. And interface supports a functionality of multiple interface inheritance. We will see this point in the next example. And we can define interface with interface keyword. And class extends another class, an interface extends another interface, but a class implements an interface. This also in the next point we will see. In the last point, can we can create an object reference for the interface, but we cannot instantiate interface. Yes. So after implementing this interface into the class, here if you want to create any other new methods, you can add, no problem. Okay. Suppose in the interface, I have a square, circle, rectangle. Now in this particular class, I will introduce a new method. Okay, new method I will introduce. Let's say void triangle. This is the normal method. It's not a default method, not a public method. This is a default method because we not specified any access modifier. Default will be taken. Not static, not abstract. So here this is a own method which we created in the class. So here this is triangle. Okay, you can create your own method in this class. And this method is not belongs to interface. Now, can we access this method here? Just observe. It's commenting. So I created this object for the same class. I'm able to access abstract method, default method, static method. And now by using this id obj, can we access triangle method or not? Yes, obviously we can access because this method is belongs to the same class, right? So we are able to access. So triangle we are able to access. Okay, suppose if you create a object for the class, but the variable type is interface. In this particular case, can we access here sh dot triangle? Can you access or not? Sh dot triangle. You cannot access. You cannot access. Even though you created this object for the class, you're holding it into interface variable. So in this interface, there is no triangle method, right? There is no triangle method. So you can't access sh dot triangle. So this is giving an error. This is giving an error. So what is giving an error? The method triangle is undefined for the type shape. So this method is not available in the shape interface. So that is the reason we are not able to get. Even though we created an object for the class, still we are able to hold it into the interface variable. So through that interface variable, we are trying to access triangle. This triangle is actually belongs to this class, not with the interface. That's the reason we cannot access. Okay. Everyone is able to understood this. This example, all points are clear. Now I will show you how to achieve multiple inheritance using this interface concept. sh dot rectangle. sh dot rectangle is what basically a static method, right? That static method you can access everywhere. Directly using shape interface you can access. Directly by using object also you can access. Everywhere you can access. Because that is rectangle is a static method. Rectangle we created in the interface. That is a static method. And whenever you implement, that is also belongs to the class. So static method, static variable always try to access directly. There is no object is required for them. Yes. Okay, directly you can try to access them. Can we access variables in interface demo which is not declared in the shape? Okay, can we access variables in interface demo which is not declared in shape using shape reference? Yes, variables also you can access. So basically what is type of variables are static and final, right? So static, by default static is there. So again, you can access these variables directly by using interface name. You don't need any object for them. You can directly access the static variables directly by using interface. Wherever you see static, don't think about the object. Forget about object. Access directly from the interface name. All the variables. Okay, so for example, here I want to capture the values of variables. Simply you can say shape dot. You can see length and width. You're able to get shape dot length into shape dot width. I'm just calculating something. Then you can print something. Shape dot length into shape dot width. Length and width are what? Static variables. So that's the reason we are able to directly access it. So accessing static variables directly. Okay, you can also do like this. If you have a variables static, because by default they are static. So that's the reason you can directly access. You don't need to access from the object. Object is not needed. Yes. So if you want to declare any new variables in this particular interface demo class, you can create your own variables. No problem. You can create your own variables in this, and those variables you can access again through the object of this class, not from the shaper. Got my point? See, here we have created one new method called triangle. All right, so that method we're able to access only through the object of the class. But when you create a variable for interface, here we are not able to access. Got my point? Why we are able to access? Why we are not able to access triangle? Because this triangle is purely related to this particular class. Similarly, if you create variables also in this class, those variables we can directly access from the object, just like a triangle method. But you cannot access them by using interface variable. Same concept is applicable for variables also, just like a method. So you can create a variable like this. Suppose in this interface demo, you can create, suppose if you create a variables here again that we cannot directly access from the main method, only through object you can access. Let me create some variables. For example, here I'm creating some x comma y. Okay, two variables I created. Okay, let me make it as 100 and this is a 200. And these variables are belongs to what? Class variables. And this triangle method is also belongs to the class. So these are all ultimately belongs to what? Class. So here by using this object, we're able to access a rectangle, right? Same thing by using this object id obj. Okay, we can access x and also I'm just adding those two numbers id obj dot y. So we can access like this. You can directly access. Just like a method, we can also directly access variables. Okay, but here it is fine. But when you come here, triangle method we are not able to access. Why? Because triangle is related to interface. Through this SH we cannot. Triangle is purely related to the class, interface demo class. So this is the new method which we have created. This is not belongs to interface, so we are not able to access it. Same thing here when you're trying to access this one, same variables. You're trying to access this, and instead of object, I'm directly saying sh. Sh is a variable of interface, right? So when I say sh, we cannot access it. We cannot access this. Why? Because this x and y is belongs to the class, but not interface. So guys, understood any confusion here? So don't go beyond that, just practice only this much. And again, you will be confused. Yeah. So now let us see how can we implement multiple inheritance using interface. That's the main objective, right? So class we cannot achieve, but interface we can achieve. Okay. So let me show you a scenario now. Let us say I have one interface called I1, another interface called I2. These two interfaces I'll implement by using a class. So what type of inheritance it is? There are two parents, one child. Two parents, one child. So multiple inheritance, right? So now we will implement that. The same type of inheritance we will implement. So I1, I2 are the parents. They are interfaces. Okay, now in day 16, I will create new interface. Instead of class, I can directly create an interface also. You can find one option called interface. So let me take this interface. Here we have to provide the interface name. I'm just giving I1 and simply say finish. So now it is directly created an interface. Okay, in interface, in this I1, I will define some variables and methods. I will create one variable int x equal to 100. And by default, this variable is what? Final and static. And I will also create two methods. One is void m1, and this is what? This is abstract method. Okay, abstract method. For now, let it be there. So this is the implementation. This is the interface one. Now, similarly, I will create another interface. Create new interface. I'll name it as I2. And in this also, I will create a same one variable and one method. Okay, in I2, I will create one variable. Let's call it as y into y, 200, and then m2. This is also abstract method. So now I have created two parents. I1 is one parent, I2 is another parent. Both are interfaces. They're having one variable and one method. Now, these two interfaces I can implement by using one single class, which is child class. So for that, I'm creating another class, new class. I will call it as a C1. C1. And here I need main method. Click on finish. Okay, just observe. Okay. So this is one parent. I1 is one parent. I2 is another parent. Now C1 should implement these two parent. So what we can do now? In the C1, I can say implements, right? So we should not say extends here. Implements. Two interfaces we have to implement. So implements I1, comma I2. You can specify n number of interfaces. It is allowed. But in case of extends, it is not allowed. Only one class we can extend. But here implement it allowed multiple interfaces. So now C1 implements I1 and I2. As soon as you say implements I1 and I2, C1 must implement abstract methods which are coming from I1 and I2. So M1 is one abstract method coming from I1, another one M2 coming from I2. Now we need to implement those methods in the class. So let us try to implement M1 in the C2 class or C1. So how to implement? Void M1, sorry. Void M1. Right? So inside this M1 method, I'm trying to access the variable directly. So I can say, because I can have X, right? So that X I can directly access. I'm just trying to print the X value. So whenever you are implementing this M1, you must specify the public access modifier, right? Because this is the default method. Earlier, it is a public method in the interface. So it should be public. So we have implemented. Now another method, public void M2. M2 is coming from what? I2 interface. So here also I'm trying to access Y value. Okay. So now we have implemented two methods, M1 and M2, which are coming from I1 and I2 interfaces. This is X and this is Y. Okay, why it is giving an error? So Y cannot be resolved as a variable. Okay, sorry, it is a uppercase. Okay, so now we are able to access everything. M1, M2 is implemented. So now come to the main method. How can we access these methods? Through the object. Through the object. So let us create an object for C1 class. C1 obj equal to new C1. So now by using this C1 obj, I can access M1. Then by using C1 obj, I can access M2. So when I execute, this will get the values of X and Y. Okay, now this is an example for multiple inheritance. So I1 is one parent, I2 is another parent. So these two interfaces we have implemented by using one child class. Implemented methods and we are able to access. This is called multiple inheritance. Now I'll tell you one more type. Just observe. This is I1 interface. This is I2 interface. These two have implemented by using C1 class. Okay. Now, suppose I have another class, let's say called the C2 class. Along with these two I2 parents, I have another parent, but this is class. This time it is a class. I want to get that also. Along with these two interfaces implementation, whatever is there in the C class, whatever is implementation variables are there in the C2 class, I want to get them into C1 class. Then how it is possible? So here I1 and I2 we use what? Implements. For class to class, what we need to use? Extends. Now, can we use the combination of implements and extends? Yes. Okay. But the first we have to do extend, then we have to use implements. First extends, then implements. This is the approach. Okay. Now we will try to implement this. See, I will create another class, another parent. I'll call it as a C2. Okay, C2. And take this class. So in the C2 class, I will create one variable, int z equal to 300. Also, I will create one method. Here we can have implemented methods, M3. And here I'm directly printing the value of z. Right? Now this is a class. So now I have already implemented I1 and I2. Now I want to extend C2. How to extend the C2? First, we need to extend here. C1 extends C2 followed by implements. So extends keyword allowed only one class. And after that, you can implement n number of interfaces. Okay. Now, by using this C1 obj, we can access everything from C2 also. So let me just call C1 obj dot, what is that method name? M3. So this is actually coming from the C2 class. You can access it. Okay. So this is called multiple inheritance. Multiple inheritance means multiple parents, one child. You can have n number of parents if they are interfaces. But if it is a class, there is only one parent allowed. So we can write like this. First, you can do extend, then followed by implements. Extends allowed only one class. Implements allowed multiple interfaces. This is called multiple inheritance, which we can achieve through interface. Okay, now I'll tell you one more thing. We have something called hybrid inheritance. That is another type of inheritance. We have understood single inheritance, one class to another class. This is called multi-level inheritance. And this is called hierarchy inheritance. One parent, multiple things. And this is called multiple inheritance. This is hierarchy. This is multiple, right? Multiple parents, one child. Here, one parent, multiple childs. If you combine these two, you will get hybrid inheritance. For example, one parent to two childs. Again, for these two childs, there is one child. Sorry, for these two, again, there is one child. So this is called hybrid inheritance. Hybrid inheritance. So how can we achieve this? So anyway, these are the two parents we have to implement using this class. So these two should be interfaces. And this can be a class. Then how can we achieve this? You guys can think. How can we achieve this? Hybrid inheritance. How can we write this statement? Let us assume this is I1, this is I2, this is C2, this is C1. Okay, now you tell me how to write this statement for hybrid inheritance. See, the ultimate goal of this is what? Whatever is there in the C2, whatever is there in I1 and I2, everything we should get into the C1 class, right? C1 class we should get. This is the grand child of everything. That's our ultimate goal. So first we will get these two interfaces implemented by using C1, and we can extend the C2 directly from C1 to C2, C2 to C1. So C2 to interface is not possible. This is not possible, right? Class to interface, not possible. Right? So what we can do now, C1 can extend the C2 directly and implements I1 and I2. Same thing we have done, right? Same thing we have done here. So this is also hybrid inheritance. If you don't have this class, only if you implement I1 and I2, that is multiple inheritance. And again, if you added one more class additionally here, this is hybrid inheritance. So hybrid is nothing but what? Hierarchy plus multiple inheritance. Hierarchy plus multiple. If I look at here, this above portion is hierarchy. The lower portion is multiple. The combination of hierarchy and multiple is called hybrid inheritance. So that we have achieved by adding another class. Okay. So this is how we can work with the interface concept. So is this clear, everyone? So what is an interface? How to create an interface? What interface contains? And how to implement interface by using a class? And how can we achieve multiple inheritance using interface? So we have seen all these points. Now, final step. We will compare interface with abstract class. So whatever we have achieved through interface, same thing we can achieve by using abstract class also. But there are some differences are there. So let us see what are those differences. What is an abstract class? Just like a normal class, abstract class, just we put abstract keyword. If it is a normal class, we create a class like this, class test. This is a normal class. It is allowed to create static methods, non-static methods, okay, all the variables and everything we will able to create in the normal class. If it is an abstract class, suppose in front of this class, if I create an abstract keyword, then this class becomes the abstract class. Whenever the class becomes the abstract class, here we can create abstract methods. Okay, and if a normal class not allowed abstract methods, only abstract class can allow abstract methods. So here you can create any method which is abstract method. But again, you have to write an abstract keyword in front of the method. Abstract keyword must be specified if it is a class. But in interface, we have never used this keyword. Have you used anywhere abstract keyword somewhere in interfaces or anywhere? No. We just created a method like this. This is abstract method. But in case if you want to create an abstract method in the class, that class should be abstract class. In front of the method, we have to specify the abstract keyword. Okay, that's a major difference. Now, let us see the differences, other differences between abstract class and interface. So interface works more efficiently, especially in the data abstraction. So let us finally compare interface abstract class. Perspective important, but in the real time, most of the time we prefer to use interface only. Okay, so let us compare these two. Okay. Now the first point, because you already know interface, you can easily understand abstract class. When I create an abstract class, can have abstract as well as non-abstract methods also. In abstract class, we can create abstract methods as well as non-abstract. Non-abstract methods in the sense, normal methods, implemented methods also we can create. But in interface, abstract methods allowed. Implemented methods are not allowed. If you want to implement, those methods should be default or static methods. If I don't specify default or static, definitely they should be only abstract methods. Right? So which one is more abstract here? Abstract class or interface? The abstract class allowed abstract as well as non-abstract, means unimplemented or implemented methods also allowed. But interface, implemented methods are not allowed. So interface is more powerful than abstract class. That's the first point. Abstract class have abstract as well as non-abstract methods, whereas interface have only abstract methods. If you want to implement, they should be default and static methods, but non-abstract methods you cannot create. Now the second point, abstract class doesn't support multiple inheritance. Means suppose this is one abstract, this is one abstract class, this is another abstract class. We cannot get it into one class. So those two parents cannot be classes. It can be normal class, it can be abstract class, cannot be two parents. So multiple inheritance we cannot achieve by using abstract class. Only through inheritance we can achieve multiple inheritance. Third point, abstract class can have final, non-final, static, non-static, all types of variables we can create. But in interface, allowed only static and final variables. I hope this point is clear. In the abstract class, all types of variables we can create. But in interface, by default, the variables are static and final. But in abstract class, if you want to create a final variable, if you want to create a static variable, you have to specify the keywords. Final, static, these keywords explicitly you have to write. But in case of interface, you no need to write those keywords also. By default, the variables are static and final. That's the third difference. Fourth difference. Abstract class can provide the implementation of interface. Okay, suppose if I have an interface, the interface we can implement by using a normal class, right? Normally. So the interface can also implement by using abstract class. So interface to abstract class also we can use implements. Abstract class can have implementation. That's the reason it is possible. Okay, interface can also implement it by using abstract class just like a normal class. That's the point. Abstract class can provide the implementation for interface, but interface can't provide implementation of abstract class. Vice versa is not possible. Why? Abstract class contains implementations, but interface doesn't have any implementations. So class to interface not possible, but interface to class it is possible. We already covered this point earlier. Now, the next point, fifth point. The abstract keyword should be used to declare the abstract class, but an interface keyword used to declare the interface. We already know this. Now, the sixth point. Abstract class can extend another class, another Java class, and implement multiple Java interfaces. See this, abstract class can extend another Java class. Suppose I have one class, normal class. This can be extended into abstract class. Here extends keyword work. Class to class, even though it is an abstract class to class only, right? Extend. So abstract class can extend another Java class and implement multiple Java interfaces. I1 and I2 is there. So these two also can implement in the abstract class. So one class we can extend, multiple interfaces also we can implement by using one abstract class. This is also possible. But an interface can extend another Java interface only. Interface to interface, we can only do extends, but not implementation. Seventh point. An abstract class can be extended using extends keyword. Obviously, we already know that. But interface can be implemented using implements keyword. Next point, Java abstract class can have class members like private, protected, and everything. See this. In abstract class, we can create methods with the different access modifier. All kinds of access modifiers allowed. Private, public, protected, default, all kinds of access modifiers allowed for those methods in abstract class. When you come to the interface, all methods are public only. Only public is allowed. Okay. And in abstract class, we can create the methods with any type of access modifiers. But in interface, everything is a public. Now, last point. How to create abstract class? We use this keyword abstract class, class name, and the method in front of the method also we have to specify the abstract keyword. But in interface, you no need to write abstract keyword anywhere else. So by default, this interface is allowed abstract method. This is your abstract method. So these are the differences between abstract class and interface. Okay. So just remember these points, interview perspective, it will be useful, but in the implementation, whenever we want to achieve data abstraction, we always prefer to use only interface. Okay. Even Selenium WebDriver itself is an interface. After that, the WebDriver interface is implemented by using different classes, Chrome driver class, Firefox driver class. Okay, edge driver class. For every browser, there are different classes they have created. And those classes are implemented same interface, which is WebDriver. WebDriver itself an interface. So based on this concept, the whole WebDriver, Selenium WebDriver component is developed for automation. Okay. So again, that time I will repeat how WebDriver they have created, how the classes are implemented by using WebDriver. Because if you understood this concept interface, you can easily understand that. Right. So this is all about multiple inheritance we can achieve with interface concept. And interface is a concept through which we can achieve data abstraction. And that is a concept. Okay. So we'll stop here for today's session, and tomorrow's session we'll continue with another concept. So with this, we have successfully completed with object-oriented programming concepts. So what are the object-oriented programming concepts so far we covered? Let us list out here. OOPS concepts. Can anyone tell me one by one? First, class, then order, object, then after that, polymorphism. After that, encapsulation, then inheritance, then data abstraction. These are the 6 concepts which are belongs to object-oriented programming. So class and object is related. Methods are belongs to class. Now polymorphism we can achieve with what? Polymorphism we can achieve with what? Overloading. Again, we have overloading, constructor overloading, method overloading. One thing can have many forms. Now encapsulation we can achieve with what? Setters and getters. Inheritance. Overriding. Overriding comes under the inheritance concept. And data abstraction we can achieve with what? Interface or abstract class. Okay. So these are the object-oriented programming concepts. Interface comes under data abstraction or inheritance. Data abstraction. And also it will support inheritance, multiple inheritance. Okay, one class we can extend it to another class. It's called inheritance concept. We can apply for classes as well as interfaces. Inheritance concept is applicable for classes as well as interfaces. Okay, so in the next classes, we will discuss some more concepts like access modifiers, private, public, protected, default, when we have to use, how we have to use. And then we have to discuss about exception handling. And then we have something called collections. So these are the concepts we will discuss in the next 2 to 3 sessions. And then we will finish it. Okay. So I'll stop here for today's session. Tomorrow we will continue that.